first thing we want to do is we're going to create, actually, first thing we're going to do is activate or execute these lines. So we get our data fed in. Remember our field experiment data that we've used multiple times. Just as a refresher, there are 210 designated market areas. Each one of those, we have measurements on their advertising channels for 21 different days. So we had a 3-week period that we have measured here. And right now, we just want to look at the data from Chicago. So that is, so FEXP SCHIC for Chicago. We're going to start with our field experiment data. And then what do we have to do if we want to pull out only the observations from Chicago? We use which verb? Select is not the right one because select is what? Select is variables, right? That's how you select column. Yeah, we want to select observations or rows, which means we use filter. And we want our DMA name to be, which means double equal sign, and then a Chicago IL. So it might be the case that not all of them you know exactly the string of characters, which means you might have to look it up. But Chicago IL is what it is here. And there are 21 observations. That's one DMA. We have 21 days of observations for each DMA. So that seems like it worked. Okay, the next question. Online advertising is often pay-per-click. So an advertiser only pays when somebody clicks on their ad. So that means we should see this positive correlation between the clicks in a particular day and the amount we spent on that day. So we want to take a look at that. So we're going to create a scatter plot. We want to compare clicks from their Facebook retargeting ad specifically, and then the amount spent in that channel. So it might be the case that you forget, wait, what are the names of the variables? There's a few ways you can take a look at that. I'm going to go down to the console window and I'll just say names of FEXP. So we can take a look at the different variables we have here. So we have Google prospecting clicks, Google retargeting clicks, Google brand clicks. So this is going to be our Facebook retargeting clicks is going to be our measure of Facebook retargeting clicks. And then we also have the amount spent in that channel. The amount spent is Facebook retargeting spend. Okay, so those are the variables we're going to be using here. Just a basic plot. So we start with ggplot. First entry is, of course, the data, which is going to be FEXP SCHIC for our Chicago data. And then on our X variable, we want Facebook retargeting clicks. And then Y, make sure it's Y is under, lowercase y, is our Facebook retargeting spend. Unfortunately, it's not popping up with the variables, so I have to type it all the way in. Okay, last time we asked, hey, actually, why didn't I put data equals FEXP SCHIC? I usually try to have that habit just to make it clear, but you don't actually have to say data equals. And just a quick secret, you don't actually have to say X equals and Y equals. You can just type them in, but sometimes I forget and I'm uncertain. I think it's you type the X variable first and then the Y variable. But because I don't want to accidentally get that wrong, I just type X equals and Y equals on that. Okay, after that, we do our plus sign. Make sure you have both of the closing parentheses, of course. Plus sign, and then for a scatter plot, we use what command?
Geopoint.
Geopoint. Point with an N. Okay, so we can clearly see the positive correlation. In 2 weeks, we'll be working in depth on correlation and regression. So, but we can see this positive correlation as clicks go up, spending also goes up. Why isn't this perfectly correlated, right? If you pay per click, why wouldn't it be, and it's on the same channel, why wouldn't we have these be on a perfect line? Right? Why is there variation on that line, right? If you pay $2 a click and you have a certain number of clicks, you should just be, if you get however many clicks that is, 16 clicks, it should be 32 bucks, right? Like, why is there variation on there? Clearly, you don't always pay the same amount, right? And that's the way it works on all digital channels. Basically, the amount you spend per click or per impression changes across time. But okay, so we see this positive correlation. We also expect to observe a positive correlation between our clicks and our impressions. So we want to redo the same plot, but we're now going to map impressions onto size. Okay, so that means that's a third mapping, and I've gotten this I've given you quite a bit of instruction on mapping means it goes where. So we're doing the same plot, but now we want to map Facebook retargeting impressions, the number of impressions, onto size. How do we do that mapping? Which part of all this code?
In the aesthetic.
Yeah, in the aesthetic statement, right? Yes, very good. Okay, so we say size equals Facebook retargeting impressions. And just to reiterate, we do our mappings in the aesthetic statement. In the aesthetic statement, a mapping is we want things to change depending on the values we see, right? If we put size equals 3 here, what does that do? Well, it wouldn't work because it's capital size, but if it were lowercase, size equals 3, that changes all of the points to be exactly the same size, a little bit bigger. 3 would be a larger size. So everything would be the same size. So anything you put in the geom applies to all of the data points equally. And the aesthetic statement is where we do mappings, which means we say, hey, we want the size to change depending on Facebook retargeting impressions. So that means the size of these dots is going to change. How are they going to change? If we think there's a positive correlation, what do we think these dots are going to look like? Which dots will be larger and which ones will be smaller? Positive correlation means higher values of clicks and higher values of spending should mean higher values of impressions. And since we mapped size onto impressions, these dots up here should be larger than the dots down here where the values are smaller. Does that make sense? Correlation means bigger, right? So if we execute that, we do see smaller dots here, bigger dots here, meaning impressions are higher up here than down here. So we have, this is a correlation across 3 different variables, but it's clearly not as easy to see correlation from size than it is from actual mapping on an X and Y coordinate system. All right, we want to compare Chicago with Philadelphia. So we're going to create a new data frame, FEXP CHPH for Chicago and Philadelphia. So we'll start with that, FEXP underscore CHPH, only we want it in lowercase, FEXP CHPH. Okay, we're starting with our FEXP data. We're going to filter again. It's going to be a DMA name. Tell me what to write. We can use a shortcut or we can do it the long way. Do you remember the shortcut? How do we select both Chicago and Philadelphia? I'll give you the long way. One would be, say, DMA name equals Chicago IL, or DMA name equals Philadelphia PA. Right, that would be the long way. Right, we say it's going to be this or this, which means we're going to have a bunch of true statements. And if either one is true, then we'll get both of them. The shortcut is DMA name in Chicago IL or Philadelphia PA. Let's see if that worked. Now we have 42 observations. It seems like it worked, right? 21 observations for each region. But now it says, okay, we want to plot Facebook prospecting clicks by Facebook prospecting spend. Size is mapped onto sales, and we want different colors for the 2 DMAs. And then make it halfway opaque. So all of this, we've saved it, so we can just start with ggplot, and then our data is FEXP underscore CHPH. Okay, so that's a lot of instruction here, but luckily we can just do things one at a time. This isn't actually a more complicated plot to do, it's just more steps, right? So it's not figuring out how to divvy the data up in some way, it's just simply more mappings, more to type on, right? So we say Facebook prospecting clicks is on the x-axis. So x equals Facebook prospecting clicks. Then Facebook prospecting spend on the y-axis. Then we want size onto sales. Okay, let's go back to our variables here. Can anybody identify what the sales variable is here? There's 2 variables here, Amazon US sales and Shopify US sales. Any idea which one it was? So this is sales on their website. That's Shopify. So Shopify US sales. Amazon US sales is actually sales via Amazon, which is not what we're interested in right now. So we got Shopify US sales. Okay, and then we want different colors to the two DMAs. How do we give different colors depending on the DMA it comes from? Good work. Yeah, color equals DMA name. I believe that's all of the mappings. And we want another scatter plot, so that's easily genome point. But it says pass in the appropriate parameter to make points halfway opaque. You remember that? It's been a couple weeks.
The
Alpha, nice, yes. Alpha equals what? 0.5, halfway. Okay, so there's a lot going on there because we can see it's very easy to say, okay, pink is Chicago, this aquamarine or whatever is Philadelphia. Okay, we can see this definite correlation between the number of clicks and the amount they've spent on advertising. Okay, do we see a really clear correlation between sales and clicks or sales and advertising spend? It's harder to assess this because it's based on the size of the points. If we think there's a clear correlation, we should see bigger points up here and smaller points down here. Do we see a clear correlation there? Not really. Yeah, we can see sales and advertising in general tend not to be as highly correlated as you might think, right? Because sales are generated by a lot of things, not just your advertising, right? Okay, now it says do that plot again. Use shape instead of color to distinguish data from the two DMAs. I'm going to do this quickly because we have a lot to get through. So same plot, which means we can copy it, but instead of color, we use shape. We have lots of mapping options. In terms of your personal opinion, which do you think of those two plots? Which do you think is better? This one or this one?
Color.
Color is the default. Like if you want to distinguish things, color just jumps out way easier than shape. Okay, now we're going to do a little bit more practice with dplyr. We want to look at only at the top 40 DMAs, which I told you is which is easier to do if I tell you exactly what that is, and that is population above 750,000 will give you the 40 most populous DMAs. Okay, so we're going to start with FEXP. We're going to call it FEXP top 40. Starting with FEXP. Oops, that's not right. What did I do wrong there? I'm trying to create a new data frame. There we go. Now, what verb do I use to get down to the top 40 DMAs?
Slice max.
We could use slice max. Yeah, we could use slice max, but I'm going to use filter. The reason is because you say filter, what I'm going to do, population above 750,000. The thing to remember there is that every DMA has a population attached to it. So the population is repeated for every DMA. It's just repeated 21 times, right? And so if I just say, hey, population above 750,000, it'll give me every observation from every DMA that has a population greater than 750,000. If we did slice max, and then we said based on population, and then say 40, I think it will give me all 40 of those as well, because ties, remember in a slice max, it gives you, in that case, we'd probably have to do group by DMA name and then slice max. No, we wouldn't want to group by. Yeah, anyway, slice max would probably work, but only because of all those populations were tied. But this way, so now we have 840 observations. That's 40 DMAs times 21 observations for each. All right, now using this FEXP top 40 data frame, create a scatter plot of Google prospecting impressions on the x-axis, Google retargeting clicks on the y-axis with a 50% opacity parameter. So this is a little bit different kind of plot here. Well, it's still a scatter plot, but we're looking at something a little different. Instead of the same channel, we're looking across different channels. So we're looking at top 40. And then we're mapping on the x-axis, we want Google prospecting impressions. Prospecting impressions. On the y-axis, it asked us for Google retargeting clicks. And that was it. So no other mappings. And then a 50% opacity parameter. So we're still going to use geom point for a scatter plot, and then alpha equals 0.5. Okay, how correlated are those two things? So this is the number of impressions on Google prospecting, the number of clicks on retargeting. So two different channels, still within Google, but two different advertising channels within those, and across 40 different DMAs. So is there a positive correlation? Yes, there is. Is it very strong? Not really. Okay, but that one, it's not a great, we have a ton of overlap here, and there's just too many data points, right? So this time we're going to do the same plot, but we want only 40 data points, one for each DMA, which is going to be the total number of impressions and the total number of clicks from that DMA. Okay, I think on the assignment I was a little more explicit because this one I didn't tell you which channels. Do we want total impressions from all channels or total impressions from just the Google prospecting or Google retargeting? I think we want from all channels here. So I think on the assignment I was a little more explicit, but here I'm going to assume we want all total number of impressions. That means all 5 advertising channels. So instead of starting with our ggplot, we're going to have to start with FEXP top 40. And now we need to actually calculate the total number of impressions and the total number of clicks for each DMA. Okay, so how am I going to do that? Group by summarize. Nice. Yes, good instinct. So we're group by DMA name because we want this calculation done for each DMA. And now we want to do our calculation. So we want the total number of impressions. So I'll just call this tot imp. What does that equal? Okay, we're summing. And what are we going to sum?
Ones that end in impressions.
Yeah. Yeah. Should we try the ends with shortcut? Let's try it. All right. I don't think I've actually done this yet. Ends with, and then we say impressions. Okay, what that's going to do, ends with impressions, is going to select, I think, let's take a look at the names. I'm going to open this back up again. Okay, our names, we have Google prospecting impressions, Google retargeting impressions, Google brand impressions. Then we have Facebook retargeting, Facebook prospecting impressions, Facebook retargeting impressions, and Facebook other impressions. I think all those are 0 anyway, so that's fine. Okay, so we're gonna select all. Sum ends with impressions. I'm not sure if this is gonna work. We're gonna give it a try, but I'm not sure that's gonna work. Okay, well, let's try this, and then we also want total clicks. That equals sum of, and we're going to try this ends with again, but again, I'm kind of skeptical. And I'll tell you why in a second. Clicks. All right, let's see what this does. Instead of trying to pipe this directly into our ggplot and then plotting it, let's see what happens here. Okay, we get an error. Ends with impressions, so clearly it's this problem here. Unfortunately, I'm not seeing. Okay, maybe down here we'll see it. See tidy select, FAQ selection context, ends with impressions. Okay, the problem I think is what's happening here is ends with impressions. We're selecting 6 different variables, and then what is the sum doing? The sum isn't saying add them all the numbers together. What the sum is doing is actually summing across observations. Remember, within a summarize statement, the sum sums across observations, but we have 6 different columns of observations. So it's trying to sum, but then we just have 6 columns. We haven't told it what to do with those 6 columns. The sum only says sum across observations. What do we do with the 6 numbers that result here? Right? We actually have to add those up. So if we take tot imp equals sum of Google prospect impressions, Google retargeting impressions, plus Google brand impressions, plus Facebook retargeting impressions, it's adding those 6 numbers up, and then the sum is adding them this way, so we get their single number of all of the impressions. So I think that is why this ends with doesn't work here, is because when we select all 6, it doesn't know what to do with those 6 because we haven't given it a we're gonna do an experiment, and we don't have time to do this, but I'm gonna do it anyway. What if we sum twice? I don't think this is gonna work, but I'm just really curious now. What if we sum across those? Does that work? I don't think it will. I'm gonna go on record as saying my forecast is this is not gonna work because sum is usually across observations. Yeah, that doesn't work. Okay. So that doesn't work. So what we have to do is we have to say, and I'm going to call an audible here, and we're just going to look at Google prospecting impressions. Or, yeah, Google prospecting impressions. Okay. And then I'm going to use Google prospecting clicks. And the reason for that is I need to speed this up here. Okay, I think that should do it. All right. Oh, our sum needs a closing parentheses there. Okay, so remember what that's doing. What we normally would do to get all of the impressions, we have to say Google prospecting impressions plus Google retargeting impressions plus Google brand impressions, all those things added up together. And then that will get them added across the columns. But then to add across the rows, we need that sum. Okay. But I'm just, whoa, stop. Holy cow. That was annoying. It got jammed and just started. Jeez. I just hit backspace once, I promise. Okay, hopefully, can I get everything? Okay, so now I have total number of impressions, total number of clicks within that one channel. It should be all channels, but to make it quit faster. Now we want to plot those. So we pipe that into our plot. ggplot, we skip our data statement since we already have the data plot in there. And then we say x equals what? Tot imp, right? Our new variable from this data that we just created. And then y is going to be tot clicks. And then we'll just make that geom point. Okay, I'm going pretty fast, but what do we notice about this relationship between impressions and clicks now? Relative to up here. We got rid of the within day variation, right? So the daily variation adds noise. Once we got rid of the summary statistics tend to have less variation in them. So regions with higher number of impressions also had higher number of clicks, and the correlation is a lot stronger. Okay, so the reason those are higher, and this is something we have to control for. Now we're putting on our actual business acumen here and thinking about what this data means is we have these regions with higher impressions and higher clicks. Those must be better regions. Well, what really is happening is those are the regions with more people, right? That's just more population there. We don't know that those are actually better for us as a company, right? So now what we want to do is we want to take a look at which regions have a higher level of sales given the population, right? How much do we, in which regions do we have a higher per capita sales, which means our concentration of sales is better. Okay, so what we're going to do is we're creating a data frame called top 40 ratio. Okay, but we can't do that yet. Let's start with FEXP top 40, right? Well, wait, what am I doing? Sorry. Top 40 ratio gets, right? That's what we're starting with. Brain freeze there. Sorry. Okay. All right, so we're starting there. We're going to create top 40 ratio. And what we want to do is we want to create a variable called the ratio. Okay, we want to calculate the ratio of sales to population for each of the 40 DMAs, but we want that totaled across the 21 days. Okay, so step by step, what we have to do first is we want the total amount of sales that happened in each of those 40 regions. Okay, so let's do that first. How do we get that? We want the total sales in each region. Group by summarize. Group by DMA name. Followed by summarize. And we need the total sales. So I'm going to call this total sales. And that is going to be what? I want a total, safe bet, we're going to do what?
Sum.
We're going to sum. And the variable is Shopify US sales. Okay, we're not done. We haven't calculated our ratio variable yet, but I'm going to execute this now. Oops. And just see where we're at. So we have the total amount of sales in every region. Now what do I want is I want to divide the total sales by the population so that I can get like the per capita sales or the sales concentration, right? I'm going to call it ratio, but that's what I'm trying to get. The problem is in this group by summarize statement, I have the total sales, but I don't have the population. How do I get the population in here? I also want population passed on here. How do I get the population? Remember, the population is the number assigned, the population for every DMA, and it's repeated 21 times. If I sum the population, I'm going to get 21 times the population. I want the actual population number for Atlanta here, not 21 times the population for Atlanta. So what should I do to get population piped in here? Remember, this group by statement is going to take all the numbers from the corresponding to Atlanta. There's 21 population numbers. What summary statistic can I do on those numbers to just pass the population on? Same 21 numbers. I can't do a sum, but a lot of the other ones I can. What's another one? What's another summary statistic? You can do the mean, right? Because the mean, if I have, let's say 2.5 million, 2.5 million, 2.5 million, 21 times, I take the average of those exact identical numbers, it's going to be the same number, right? Mean of population. So that's how I'm going to pass on population onto here. Okay, so far we've got top 40, but in order to calculate the ratio, what I want to see is what is the sales concentration? What is the sales relative to the population? And so now I want a variable called ratio. How do I create a new variable? Mutate. Nice. And I'm going to call this ratio equals total sales divided by population. I'm going to trust that that worked. And now I want to create a histogram of those ratios. Okay, so I'm going to say ggplot top 40 ratio, our new data frame that has all those ratios in there. Okay, aesthetic statement, like always, the only difference with a histogram is I only specify the X variable. So I'm going to call this ratio. And now I do geom underscore histogram instead of geom point. Okay, so the overall ratio is not super high. We get like 2 cents per person, 1 cent per person, 3 cents per person, but we have some regions that have a much higher concentration than others. Okay, so now we're going to create a bar plot of each region's sales to population ratio. Okay, we use geom_call in lesson 3. So we're going to use geom_call to create this plot. But we want to, actually I'm going to start there. We'll do those modifications in a second. So we want a bar plot using geom_call for geom column. And we just want to plot these ratios here. Instead of doing a histogram of them, we want to plot the actual values. Okay, so we're going to say ggplot, still using top 40 ratio. We're going to map. This is a bar plot. So X equals what? What we want to do is we want to see each DMA name's ratio value. So we want a separate bar for each DMA name. So we want X to be the actual DMA name. And that way we'll have a separate bar for each DMA. And then Y is going to be what? The ratio. So we want the actual to plot the ratio. And we want this to be geom call. Okay. Now that's the basic plot. We could execute it, but I'm not going to. It says order the DMAs in descending ratio order. So I want to see my best to my worst. What are my best DMAs in terms of the amount of sales in that region? Okay, and you don't actually know how to do that. So we're going to add this command, X equals reorder DMA name negative ratio. So that is actually going in place of DMA name. So take a look at that. And this is not something you're going to have to replicate on the final exam without help. But I think it's a valuable exercise to take a look at code, figure out why it works. So instead of just saying X equals DMA name and just plotting one, we say X still is DMA name, but I want to reorder those DMAs in the reverse order of the ratio value. So I want to see my best ratio followed by my next best, followed by my next best in reverse order. So frankly, this is not a command I have at the top of my head. I can't do this. I have to look this up every time. But it's useful to kind of look at that. Okay. Then we're going to do another command. This is going to be another exercise to like figure out how this works. We're going to add this command here. And we just add this right here underneath. We literally add it. We do a plus sign and then add this. This is a theme command. I think I told you with the instruction, we don't do hardly anything with theme because theme is confusing. And theme is just basically what they call the non-data inc. That is the non-data aspects of it. And that is axis.text.x. So this is the axis text on the x-axis. And it's like element underscore text. So we're going to change some aspect of the text. And we're going to change it to a 90-degree angle. Basically what that's doing, instead of trying to do the labels, we got 40 labels and they're too long to fit. I'm flipping them this way so we can actually read them. So we'll actually be able to see. All right, so this plot, now we can see, oh, it was Salt Lake City that had our largest high per capita sales, followed by Seattle is a good region for us, Denver, Austin. If we had just trusted the previous numbers, we would have been, oh, New York's our best one, followed by Los Angeles, followed by Chicago. They clearly aren't the best. They're just the most populous, right? So it turns out Salt Lake and Seattle and Denver are our best regions in terms of per capita sales. Okay, here's something you will do on the assignment. So I want to give you some fair warning on this. Okay, what it tells you to do is do that plot again, only now instead of geom call, do geom bar. So geom call gives us these bar plots. Why wouldn't we just use geom bar? Like if we want a bar plot, geom bar seems like the more likely bar plot. But it gives us an error. So I want you to actually look through the error message and figure out what is the error. So error in geom bar, problem while computing stat. That was another thing I showed you on the instructions briefly that we're not going to touch on. There's a stat layer, and that is what are the numbers if we're going to calculate some kind of statistic along with this. ggplot is really good at calculating things and then plotting that data. And the stat is the actual, what are the numbers we're plotting? So something is, while computing stat, error occurred in the first layer caused by error in setup parameters. Stat underscore count must only have an X or Y aesthetic. So the way it looks, or the aesthetic, which is like the mapping, is supposed to be a count variable. Okay, so the error that happened here is the fact that the bar plot by default counts the number of observations, and the height of the bar is the number of observations it sees. What we're trying to plot is the actual ratio, the value you see within there. So, so this doesn't work. The bar plot doesn't work to try to plot an actual variable unless, and it gives you instructions here, unless we want, so geom_bar counts the number of entries with a particular value. If we want the y-axis to reflect the actual value, like the ratio, we have to specify stat equals identity within the geom_bar. So now let's do that. Let me show you. If we copy this code, they gave us an error before. And then we say within the bar, stat equals identity. Now we get the same plot we had before. So the geom call function is, hey, give me a bar plot, but the bars should be the values in the y variable. The geom_bar function is how many observations do we have from Salt Lake? And I'll give you that many bars here. How many observations do you have from Seattle, Tacoma? That's the height of my bar. It's just the number of observations I see here. But then you say stat identity is, hey, don't give me a count. The statistic I want you to show is just the actual value you see in that y variable. That's the stat equals identity. Word of warning, on the assignment, I give you a code chunk, or maybe I'm not even sure. Basically, I tell you to give me the answer. What is the nature of that error? You want to execute the code so you can see the error, but then delete this code on the assignment, because what happens if you submit this to the auto grader? It doesn't grade because there's an error there, right? You need to turn in your assignment that's free of errors if you want it graded. Okay, so go ahead and get the error so you see what the error is, but then delete it before you turn it in. Okay, so now so we've shown how to do a few different options. Now we're gonna be doing some color manipulation within ggplots. We're using FEXP, CHPH, or Chicago, Philadelphia. We're mapping color onto DMA, size onto sales. So we're just doing a basic plot, and we're gonna start altering this. So data equals FEXP, CHPH. We're mapping X onto Google Prospecting Impressions. Y is Google Prospecting Clicks. Color is DMA name. And then size is sales, which is our Shopify US sales variable. All right, and then it's going to be geom point. So sorry I'm buzzing through this, but I want to get to the meaty parts. Okay, so this is our basic plot here. Okay, now it says recreate the same plot, but we want to use different colors. Okay, so did you learn both scale fill brewer and scale color brewer on the instruction? Because the instruction used to be the data camp stuff, and now you're not using that. I can't remember what I put in my actual video that I
Learned one.
Okay, so now you're learning the other one. Okay, so there's scale fill and scale color. So for points on a scatter plot, we use scale underscore color underscore brewer. For bar plots, we're going to use scale fill brewer. Okay, so we want to create the same plot here. But now we don't want to use the default colors. So we want to use scale color brewer because they're points. Okay, so we want to add this command, which means we actually literally add it. We're going to say scale color brewer, and then don't forget the opening and closing parentheses because it's a command. So now we use now it's going to give us different colors here. One problem though is that those light blue points, I like these colors actually, they're pretty, but the light blue points are really hard to even see. But they would be easier to see if we had a white background. Okay, so I'm going to do this plot again. And I'm going to use the classic theme. Okay, I told you before, theme is really complicated if you want to do very specific things with a theme, but it's really easy to just use a preset theme. So I'm going to use the classic theme, which is theme underscore classic, opening and close parentheses. And the classic theme does not have grid lines or gray backgrounds. So now it's a lot easier to see that stuff. You're welcome to play around with any other theme you are interested in looking into. Okay, finally, one other way to change the color is we can actually select a color palette. So I gave you a few of these options. You could also just look it up on Google. You can see a bunch of different palettes here. And I say, let's use the set 2 palette in the same plot. So if I copy all this code, and then I can say palette equals, and then in parentheses or in quotation marks, set 2. Now it uses that color theme, which is not very pretty, but that's how you do it. Okay, so that's a few different options for choosing colors, manipulating colors. I think I also told you how to manually select a color, right? So those are all options. Store them somewhere or figure out a way you can look them up. This is not something I anticipate you'll be able to or want to memorize. I myself don't have all these options memorized, but I can, with a quick Google search, figure out how to do it again. Okay, here is a really key thing that none of you probably know how to do yet. Or if you do know how to do it, it's going to take you a while and it's going to be kind of onerous. All right, we want to create a categorical variable for population. Right now, our population is a continuous variable. It tells us the actual number of people in that region, right? We want to create a categorical variable. We just want large, medium, and small across our top 40, right? So 3 for the plus 2 million population regions, a 2 for the between 1 and 2 million populations, and a 1 for the less than 1 million populations. Okay, so that's going to be, we're going to create popn2. So it's going to be a new variable, which means we're going to use what? Imply our verb. Yeah, we're going to do this in top 40 ratio. So top 40 ratio is going to get top 40 ratio. We're starting with the same data, but we use a mutate to add a new variable, and it's going to be popn2. And it's going to use popn to give me these categorical values of 3, 2, or 1. There's a few ways we can do it. One way would be to do a for loop, right? If we did a for loop, we could pre-store the value of like 1, 2, or 3 in there in popn2, and then do a for loop and go one by one and say, okay, is population above 2 million? In that case, popn2 bracket I gets 3. Else, check if it's above 1 million. If it is, then popn2 bracket I gets 2. Else, popn2 bracket I gets 1. Right? So we can do a for loop. I'm going to show you, and you should be able to do that. It might take a little bit of thought and doing. I'm going to show you another way to do this, and that is there is an if-else command. One of the biggest problems with the if statement is the if statement can only evaluate one value at a time. The if-else statement can do whole vectors and do kind of check a variety of values and give you the output. So the if-else statement, I'm going to go ahead and do the help on this. Help if-else. The if-else statement gives you have 3 inputs. The test, what is it you're testing? In this case, the value of popn. If it is above that, what value do you want to assign it? If it's not, what value do you want to assign it? Okay, so what we're going to test first is population above 2 million? So if popn is above 2 million, in that case, what do I want? I want popn2 to equal 3, right? If it's not, if it's less than 2 million, I want it to equal 2. Or I want it to equal 1 with 1. We're not sure unless what? Unless we do another if-else statement. I'm giving you a lot here right at the start, right? So now what we're going to do is our if-else statement, if it's greater than 2 million, we want it to be 3. If it's not greater than 2 million, we want it to either be 2 or 1, depending on what popn is. We don't know. So we need to actually evaluate popn again. So if popn now is greater than 1 million, if it's greater than 1 million, we want it to be what value? 2. And if not, that means it's less than 1 million, which means we want it to be a value of 1. So we have an embedded if-else statement, and I taught you if-else at the same time. So that was kind of a lot to throw at you at once. But basically, an if-else statement is going to be able to evaluate my entire vector. Each one of those is going to evaluate whether it's greater than 2 million. If it is, it's going to assign it a value of 3. If it's not, it's going to do another evaluation of if-else. And if it's greater than 2 million, this will be 2, otherwise it'll be 1. Okay, so let's go ahead and just take a look at that. Now we have pop n. Atlanta is 3, the population is over 2 million. Austin is 1, the population is 751,000. Baltimore is 1 million, between 1 and 2 million, so that's 2. Okay, seems to be working. Okay, so now we're going to recreate the bar plot we created earlier, showing each region's ratio of sales to population in descending order. But now we're going to map fill color onto this new pop n2 variable. Okay, so I'm going to go back to the code. We're going to copy this code way up here. Okay, so we have a different bar for every region, but every region has a different population size, and we have categorized those populations with this pop n2 variable. Okay, so we want the bar color to be different depending on the pop n2 value. So your instinct might be to say color equals pop n2. And that's a good instinct, it's just wrong. Okay, for this one, and the reason is why? Color changes the colors of points in a scatter plot, but how do we change the color of a bar in a bar plot? It's fill. Okay, the color will change the border of the bar, not the actual bar color, and it's hard to see border colors on a bar, so don't bother with that. The other thing, we do have to change one more thing. Pop n2 is a numeric variable. Notice it says double, that's a numeric coding, but it's only 3, 1, and 2. We don't want it to treat pop n2 as a continuous variable. It's actually categorical. So what we're going to do is say as dot factor. We've learned as before, but this is one of the main, the as dot whatever. That's a really useful function, and this is one really great use of it, is to just currently, even though it's coded as numeric, treat it like a factor variable. So as dot factor. And when we do that, we get a different bar color. So our Salt Lake City is actually a smaller region. Seattle is a medium-sized region. Denver's also medium-sized. So if we're a company, we sell all these things online and we have really great results in Salt Lake and Seattle and Denver, but we want to maximize our sales and we're thinking about starting a store or setting up a few stores, we might want to look into Seattle and Denver because there's a lot of regions. They're more populous than Salt Lake and maybe they'd be better. Okay, we want to do the same plot, choose new colors for the bars, use the dark 2 palette of Brewer. Okay, tell me what to do. If I want to use the dark 2 palette of Brewer, what do? I add the command. What's the command? Scale.
Color Brewer.
Color Brewer. And then inside here I type palette equals, in quotation marks, dark 2. So good job. You're just one problem. Instead of color, we use what? Fill. Because it's a bar plot. Okay, so now we have different colors there.
You not have to delete the fill equals as factor.
No, yeah, because the fill, that's how we got the mapping in the first place. Okay, we're out of time, but I'm going to keep going because I think there might be, actually the rest should be pretty simple, but I'm going to do this. Let's see, a little more practice with bar plots. Oh, I want to make sure you understand how this, a bar plot works with this, yeah, the stat identity. Okay. So we're going to create a plot that shows the total population of the regions within each pop n2 group. So we're going to create a bar plot that's going to have 3 bars. One for pop n equals pop n2 equals 1, one for pop n2 equals 2, one for pop n2 equals 3. And we want the bar to reflect the total population within each of those regions. So your instinct would be, and my instinct would also be, to say, okay, group by pop n2, some population, and then plot that new variable. Turns out ggplot is really cool, and it can do some pretty powerful things statistically without having to do that. So let me just show you what I'm going to do. I'm going to say ggplot data equals, I think it's top 40 ratio. Okay, and then my aesthetic statement, I'm going to say x is going to be pop n2, although I'm going to make it as dot factor pop n2. And then y is going to be pop n. And then I'm going to do geom bar. Okay, only I'm also going to add this stat equals identity because I want it to plot not the number of observations within each group of pop n2, but the actual population itself. So now notice what it does. It actually gives me, here's the total population of the regions in the 1 category. Here's the total population of all the regions in the 2 category, and all the total population of all of the regions in that 3 category. I didn't have to do group by and sum it myself. It automatically stacked them on top of each other and gave me the total population. Because it stacked, here's the population of Salt Lake and then Austin and all those smaller regions kind of just got stacked on top of each other. So if you understand how these bar plots work, this actually can be very powerful, right? And save you a lot of work. Let me quickly show you. Let's see. 2 things. So one thing you can also do is if you map fill equals DMA name, what that's going to do is each one of these bars is composed of the population slices of all these these regions. And so if I put that, then it's going to have multiple colors on each of these bars to show the different populations of each of those regions. But one thing I did tell you to do is say theme legend dot position equals none. And that's because there are 40 DMAs. If it would give me a legend with 40 lines, and it would just get really big and cumbersome. But you can see here, now I can see, oh, this must be New York right here. This is my biggest population. That's how it created it, is it took the actual value and just stacked them on top of each other. So you can color them, and you can see the different distribution of population sizes here. And then it's going to give you very explicit instructions on adding different commands. Position equals dodge, put that in the geom bar statement along with stat equals identity. So separate those by a comma, and you'll see some other things. So I think you should be able to handle those on your own. Okay, good luck.
Thank you.
You bet.